talk about condensed chemical structures. So this is a normal chemical structure on the left. That's what we've been drawing, Lewis structures, where we show all of the bonds. We show all of the lone pairs. We have all of the bonds, all of the lone pairs. This is what we have been doing. This is called a condensed structure because this is a little bit cleaner. We don't have to show every bond. If we show this, this is telling us, oh, we have carbon connected to 3 hydrogens. So this carbon connected to 3 hydrogens is the same as carbon connected to 3 hydrogens. And then this carbon connected to 2 hydrogens is like the one in the middle. Okay, so you're just taking out the bonds between carbon and hydrogen. That's a condensed structure. Okay. And then this one is condensed. When we have, do you remember what this group was called? OH at the end?
A base.
No.
Oxide?
This is hydroxy. Hydroxy, this is a hydroxy group. So if we have an OH group, we can simplify that in a condensed structure by getting rid of the bond and getting rid of the lone pairs. They're still there. The bond between hydrogen and oxygen is still there. The lone pairs are still there. We're just not drawing that. Does that make sense? Okay. So what I'm going to have you do is I'm going to give you, so these are your examples. I'm going to give you this little packet of molecules, and you're going to match the condensed structure with the normal structure. Oh, what? Sorry. That's yeah. So as soon as you can do that. So this is your examples. On yours, go ahead and see if you can find them. There's one structure that's the condensed structure, one that's the
So you don't drink Sprite. You don't drink any soda.
Caffeine and soda.
Soda has caffeine in it.
I don't drink soda.
Sprite doesn't.
Sprite does. No.
I was just like,
okay, you're like,
Sprite does not have caffeine.
Yes, it does.
Actually, you're wrong. Neither is Sprite. Those are the only 2 sodas I can't drink.
okay, yeah, that's good.
That's the best.
Alright, you were right about the Sprite. I'm gonna check.
that has condensed. But
Oh, are we just?
do we put them together?
Yeah, match them. There should be 2 that match. Or like there should be pairs. Match the pairs.
Okay, so we're trying to say condensed in the molar, or trying to get the molar on the condensed. I'm confused. Yeah. No, so
Yes, I'm right.
let me. I'm looking at it.
You got them? Alright.
Yes,
Sorry.
I think you're good.
Okay.
I'm just trying to help, dude.
Right, you're almost there.
So this one's a big one. This one's this one, I think. 2, 2, 3. Yeah, this is 2. You're sure this 2.
That's disgusting. Sorry, man. Oh, sorry, man. Oh my gosh.
Yeah, that's right. There you go.
Okay, you got it? Okay, here's the key. See if you got it right. Oh, are you okay over there? I don't know how cold it is. Okay, this is the key. Did you match them correctly?
Oh, I was right. No, we were
Was
right.
that pretty good? Like, you can do that?
Yeah.
All right. So you need to keep track. One of the Alex topics asks you to do the condensed structure. Sometimes it asks you to do a skeletal structure. That's not, this is called condensed structure. So condensed structure shows hydrogens. It doesn't show lone pairs. It doesn't show bonds between carbon and hydrogen. So we will talk about what a skeletal structure is next time. So That tricks some people on the test. So you need to watch out, make sure you're paying attention to what the question says. If it says condensed structure, this is what we're talking about, okay? All right. So the other thing that we need to practice is looking at a condensed structure and then counting how many different carbon-carbon bonds, how many carbon-hydrogen bonds there are, and how many carbon-oxygen bonds there are, and then how many lone pairs.
Oh my gosh.
So if we're looking at this molecule here, how many carbon-to-carbon bonds are there?
2.
Good. Yes, so let's draw those. Oops, where did that go? So carbon to hydrogen, or excuse me, so this hydrogen is just put here. It's not really right there. So this carbon to carbon bond, there's one. Here's another carbon to carbon bond. So that's 2. 2 carbon to carbon bonds. Okay, how many carbon to hydrogen bonds? 3. Yes, there are 3. Good. So you got 1 here, carbon to hydrogen bond, carbon to 2 hydrogens. So carbon to hydrogen, carbon to hydrogen, carbon to hydrogen. That's 3.
What about the one on the bottom? The carbon double. Or is that just?
Oh, so this would be carbon to oxygen and oxygen to hydrogen. Yeah, good question. Okay, how many carbon to oxygen bonds? This one's a little bit unclear.
1, 2,
Oops.
2, 3, yeah, there's the one on top.
So I think this is a little bit confusing. I think this would mean just 1 because there's only 1 carbon to oxygen. This would be considered a double bond. This would be like if we had, so I should change this slide. This would be if we had a carbon to oxygen double bond. There would be 1 of those. Oops, I just wrote 2. Okay, does that make sense? Okay, how many, oh, so there's 1 of these. How many lone pairs? This is tricky.
Yeah, C to the hydroxy.
Oh, yes, I missed that. Thank you. 1, 2. Thanks, thank you.
1, 2.
Okay, lone pairs. So remember, even if we didn't draw it, it still has a lone pair. You're close. It's close to 8.
Wait, what?
We're looking for how many lone pairs are there. They're not drawn, but they're still there. We still need to remember they're there. Yes, there's 7. Can you see the 7 lone pairs? 7 lone pairs. You can see them? Okay, let's draw them in. So every oxygen has 2 bonds and 2 lone pairs. So it has 2 bonds and 2 lone pairs. So the bonds are between carbon and oxygen and hydrogen. And then to fill its octet, it always will have 2 lone pairs. This oxygen is going to have 2 lone pairs. This oxygen is also going to have 2 lone pairs. And then this nitrogen is hiding over here. Nitrogen likes to form 3 bonds. It has a bond with 2 bonds with hydrogens, 1 carbon.
Or not carbon.
Yep. And then it will also have 1 lone pair. So we've got 1, 2, 3, 4, 5, 6, 7 lone pairs. Does that make sense? Okay. So even if they're not drawn in a condensed structure or a skeletal structure, they're still there. You still have to remember they're there. Okay, so the last thing we're going to talk about today is functional groups in organic chemistry. So there's a whole bunch. So if you take chemistry, you take more chemistry, it's just become part of your vocabulary. Okay, but what we're going to do, so there's a whole bunch, right? This is only 1 sheet, but these are pretty common. We are only going to focus on these ones. So what is this? 7, 8? There are 8 of these. So this is on your sheet. Does everyone have one of these? I can't even remember.
What's R?
R means a group. So it could be a hydrogen, or it could be just a carbon chain.
Okay.
R is like, we have something there, it could be many things. Usually in Alex, it just means it's a carbon chain, because they like to draw out the hydrogen.
Okay.
Okay, so you have this?
Got that.
Okay, So this is on your sheet. This is also an Alex, if you need to look at that. These are the ones that Alex thinks are important for you to know at this level. So there are 8. You either have to memorize these or write them on your note card, okay? As you get more familiar, as you see these more and more, they will become more familiar to you. So this is the pattern that we're looking for. So let's just walk through some of them. The carboxylic acid has a carbon with a double bond to oxygen. It's on a carbon chain, that's what that R means. And then it has this OH. So this is our carboxylic acid. So if we see something that follows this pattern, that's a carboxylic acid. Okay. An ester is in the middle of a carbon chain. It has a carbon double bonded to an oxygen, but then it just has an oxygen. And then another, this is a carbon group. So it's in the middle of a carbon chain, and so instead of terminating with hydrogen, the carbon chain keeps going. This is an amide group. It has a double bonded carbon, so notice we're seeing this pattern. If it has a double bonded carbon with a nitrogen, and then we have 2 carbon groups coming off of it, then that's an amide group. Okay. An aldehyde, again, we have this double bonded carbon, and then we have a hydrogen. It terminates in a hydrogen. So this only happens at the end. Anytime we have a hydrogen at the end, our carbon chain stops. Because hydrogen can't keep the chain going. It can only bond with one thing. All right, if we don't have any special groups, so we don't have any oxygens or nitrogens or end in hydrogen, and we just have a carbon double bonded to the oxygen in the middle of the chain, that's called a ketone. Okay. Are some of these starting to sound like, have you heard of any of these before? You've heard of ketone maybe? Maybe not? Sometimes you've seen this before. Where have you seen it?
In my anatomy.
Okay, so these are important in biology also. Oh, wait. Sorry. Oh, you're okay. The more you can start recognizing these, or you've heard the names, the easier it'll be. Okay, if you have an OH group at the anywhere in a carbon chain, that's an alcohol group. So if it's OH isolated, this is not OH because it has the double bond carbon right next to it. Does that make sense? So this cannot be an alcohol. This is an alcohol group because all it is the OH at the end. Okay. If we just have oxygen all by itself in the middle of 2 carbons, that's going to be an ether group. And then if we have a nitrogen so it doesn't have oxygen, so these are different. Oh. These are different because, oh no. Oh, okay. These are different because, what ones are different? I don't know what it's talking about. Oh, these ones, the nitrogen and these 2 are different. Because this one has the C double bond to O next to the nitrogen. This one just has a nitrogen. Does that make sense? These groups here could be carbon groups, or they could be just hydrogens. That would be an amide group. Okay. All right, so go ahead, let's practice some of these together. So, can you see these? Okay, they're kind of small. So look at this one. What pattern do you see? I see we have a carbon double bonded to an oxygen, and then I'm going to look next to this carbon. This carbon is bonded to this carbon. This carbon is bonded to this carbon. So I don't really have anything next to this. So this carbon double bonded to oxygen is isolated. So what would we call that? So aldehyde has to have a hydrogen, so you're close. It is in that family.
Ketone?
Ketone, yeah, good. So we have carbon double bonded to oxygen that looks just like this ketone. We have a carbon group, then a carbon double bonded to oxygen, and then a carbon. Okay. All right, how about look at this molecule? So anything special?
The carbon's double bonded to the oxygen.
Good. Carbon double bonds to oxygen. And then what's next to the carbon that's double bonded to the oxygen? What's R? So there's a carbon chain over here. And then what's over here? And a hydrogen. So that is a functional group. What is this one? That's a special one. We have a carbon next to a hydrogen. Carbon double bonds to oxygen next to a hydrogen.
Aldehyde?
This is aldehyde. Good. So we have carbon double bonds to oxygen right next to the end, right next to a hydrogen. That's an aldehyde. So notice these first two examples, Alex tries to trick you. Alex is like, oh, they will be tricked by this double bond carbon. None of these have a double bond carbon. We don't care right now. So this is like a distractor. They're trying to trick you with this double bond carbon. Okay. So watch out for that. Okay, how about this thing? What do you think this would be?
Carboxylic acid.
Yes, good. Carboxylic acid. So we have a carbon with an OH and a double bond oxygen next to a carbon group. So that just looks just like this. We have carbon with an OH with a double bond with some kind of carbon group. Good. Okay, how about this one? Yes, this would be an alcohol group. Good. That's all we have. This carbon doesn't have anything fancy around it. It has this hydrogen, but it's not double bonded, so we don't really care if that's hydrogen. So that's an alcohol group. Okay, let's try this one. What's this one? Wait, which one? We're doing this one at the top. Yeah, sorry. No, you're okay.
Would that be? Ooh, would that be ether?
Yeah. Yes, ether. So either we have just oxygen. Yep. This they're trying to trick you. They put this thing that's not an oxygen, so we don't care. We care if it's a carbon double bonded to an oxygen, not carbon double bonded to carbon. So oxygen only next to carbons, that's going to be our ether. Okay, good. Okay, how about this one? What is this?
Amide? Amide?
Yeah, good. Amide. I don't know how to say it either. I think I've heard it multiple ways. Have you heard? How do they say it in the anatomy class? This one. This. Oh, I mean, yeah. How about this one? I think I've heard mostly amide or amide. I've heard it both. I don't know. I usually say amide, but maybe that's wrong. Okay, let's jump down to this one. So this one was amide. How about this one?
It's not alcohol though.
Nope. No OH.
I was thinking it was alcohol against the amine.
Amine, because this one's amine. We have nitrogen, that's special. And then we look around, there's no double bonded carbons. So this one's amine. We have this nitrogen next to 3 different groups. Amine. Okay, what's this last one?
Ester.
Good, this one's an ester group. Carbon double bonded to oxygen. Next to the oxygen or carbon is an oxygen. In between the carbon chain, like inside the carbon chain. So that's gonna be our ester group. Okay, do you think you can do that? Okay, I think the tricky part is, as you get really familiar with these, if you use them a lot, they start becoming like you just know them. But if you don't know these, then you like need a reference, and you can't use this sheet on your test. You have to put this on your note card if you need that. Okay. All right, that is all for today. So work on either Alex chapter 11, chapter 13, lab 13, or you can do the pre-lab for lab 5. You could do the signature assignment, or you can study for the final. So we've got lots of things you could do.
25 minutes.